Key concept 11, target B.
Yeah, YouTube channel is at Math Videos by Mr. A. Make sure you subscribe so that way you know when new videos come out. Hit the notification button as well. I'll be making videos for Key Concept 6 through Key Concept 14 for Integrated Math 1 Core and Honors.
Some vocabulary to go over real quick. Like terms. In order for them to be like terms, they need to have the same variable. And they also need to have the same exponent. Okay. This is something we saw in Key Concept 10 when we were looking at laws of exponents. So same variable, same exponent. Obviously, constants are like terms with each other. Monomial just means we have one term. Binomial obviously means we have two. Trinomial means we have three terms, and then poly just means more than one. So technically, a binomial and a trinomial would be considered polynomials. When we call them binomial or trinomial, we're just being a little bit more specific to let you know, hey, there's two terms or there's three terms, and so on. Example 1, to add polynomials, we're just going to combine like terms. So example 1 says, find the sum of the following. Sum, remember, is the answer to an addition problem. If you look at example A, we're combining 6x squared plus 7x minus 10 with the quantity 4x squared minus 5x plus 6. Now, technically when we see parentheses, we should be thinking about distributive property, but in front of each one of these is a positive 1, and we already know that multiplying by positive 1 will not change anything. So I'm just going to bring everything down, but I'm dropping the parentheses. Directions were to just combine like terms. So circling the first thing I see, 6x squared. Remember, like terms need to have the same variable and the same exponent. So 6x squared will combine with a positive 4x squared. Then the next thing you have is positive 7x, which will combine with minus 5x. And then you have minus 10 that will combine with the other constant plus 6. So when you show your final answers, variables first in alphabetical order, highest exponent to lowest exponent. So that means we're going to combine the circles first. 6x squared plus 4x squared will give us 10x squared. We got rid of those. Then the squares, 7x minus 5x will leave us with a positive 2x. And then finally the constants, negative 10 plus 6 will give us a minus 4. 10x squared plus 2x minus 4 is a trinomial, it has three terms, and it is our final answer. All right. Looking at B, same process here again. There's parentheses. So out front of each one is a positive 1. Multiplying by positive 1 won't change anything, so I'm just going to rewrite it, but simply dropping the parentheses. And then shape it up. So starting with 3x squared, which is positive. That'll combine with positive 2x squared. Positive 9x is by itself, and then the constant minus 6 is by itself. So combine like terms, again, variables first, highest exponent to lowest. 3x squared plus 2x squared will give us 5x squared. And then 9x, only one square, so bring it down as we see it. The triangle, only one, so bring it down as we see it. 5x squared plus 9x minus 6, again, trinomial, and our final answer. Example 2, so it says directions to subtract polynomials. First distribute and then combine like terms. So technically we distributed before, but it was by positive 1. Notice this time around, that first parentheses to the left, 7x squared plus 5x minus 11, does have a positive 1, so that won't really change. But the second one has a negative, so we're going to have to distribute that. So first set of parentheses, I'm just going to do is bring down the first without any parentheses because multiplying by positive 1 won't change anything. However, the second one, I will want to distribute by the negative. So negative 1 times 3x squared gives me minus 3x squared. Negative 1 times a negative 8x will give me positive 8x. And then negative 1 times positive 2 will give me negative 2. Now to combine like terms like before, starting with 7x squared, that'll combine with a minus 3x squared. And we have positive 5x, which will combine with positive 8x. And lastly, minus 11 will combine with minus 2. starting with variables, highest exponent. 7x squared minus 3x squared will give me 4x squared. 5x plus 8x will give me positive 13x. Then minus 11 minus 2 will give me minus 13. For a final answer of 4x squared plus 13x minus 13. Looking at example B, same process. First set of parentheses I can bring straight down because it's a positive 1 out front. Second set of parentheses, there is a minus 1, so negative 1 times 6x squared is minus 6x squared. Negative 1 times negative 5 will give me positive 5. Now to shape it up, 11x squared will combine with minus 6x squared. Positive 8x by itself, positive 5 is by itself. Time to combine. 11 minus 6x squared will give me 5x squared. 8x by itself. Constant positive 5 by itself. Final answer is 5x squared plus 8x plus 5. Keep in mind in this video, any examples that I do, obviously you have to copy down yourselves, but then go ahead and do any that we haven't done. So if there's a C, D, E, F, so on, those are your responsibility to finish up. Example 3, determine values of the polynomial expression that would make the sum of the following equation true. So we have the quantity x squared minus 4x plus 6 plus some unknown quantity should give us 6x squared plus 3x. So on the left, I have the two quantities that need to be added together. And on the right, I have the actual sum. Okay? And I will make a note too, I just saw this right here. This parentheses should not be here. So go ahead and get rid of that. Okay. Now, they give you one of the values that was added. We don't know the other one, and then they finally give us a sum. So I'm just going to set up a simple setup right here. So I'm going to take the first thing that was added. So that was 1x squared minus 4x plus 6. Okay. We know that something was added to it, and that finally our answer was 6x squared plus 3x. So 6x squared will go right underneath the 1x squared. Positive 3x will go under the minus 4x. And then I'm going to put a positive 0 here just to show that we ended up with no constant. So then my goal is just to figure out what was added together. And it's much simpler this way, because now you're asking yourself, okay, 1x squared plus what gave me 6x squared? 5x squared. Negative 4x plus what gave me 3x? So that's going to have to be a positive 7x. And then positive 6, sorry, plus what gave me 0. In order for it to cancel out, it needs to be minus 6. So the answer will be all this in the middle. Okay, that is what we added to get 6x squared plus 3x. So final answer, 5x squared plus 7x minus 6. Okay, to multiply, just distribute. Each term in the first polynomial must be distributed to each term in the second polynomial, then combine like terms. Example 4 says find the product for each of the following. And again, we sort of did this in the previous key concept when we were looking at radicals. We'll start with A. So parentheses tells me to distribute. The 4 is immediately out front. So 4 times x will give me 4x. 4 times 8 will give me a positive 32. 1 has a variable, 1 doesn't. 4x plus 32 is my final answer. It is a binomial, which means it has two terms. Okay. Skipping ahead to C, now we have 5x times negative 6x. Keep in mind, they both have x, so we're thinking law of multiplication of exponents, which means if they have the same base, we're going to keep the same base by adding the exponents. Each one of these is being raised to 1. So you multiply the coefficients, 5 and negative 6 give you negative 30. X times x is going to give you x squared. And then we have 5x times 1, which is going to give me positive 5x. If we tried to combine like terms, we wouldn't be able to do anything because even though they do have the same variable, they have different exponents. So negative 30x squared plus 5x is the final answer. Then we have E. So again, everything in the first parentheses must be multiplied by everything in the second. So I'll start with 8d. 8d times 4d will give me 32d to the second. Again, using the law of exponents with multiplication. Then we have 8d times a negative 2, which gives me minus 16d. Okay, so I took 18 in the first parentheses and multiplied it by everything in the second. Now I need to take 1 and multiply it by everything in the second parentheses as well. 1 times 4d will give me positive 4d. Positive 1 times a negative 2 will give me a minus 2. Now we need to combine like terms. Okay, notice the only like terms we're going to be able to combine here is the minus 16d and the positive 4d. D squared, there's only 1. Minus 2, the constant, there's only 1. So bringing variables down first and the highest exponent, 32d squared. Negative 16 plus 4 will cancel out to give me, or not cancel out, but will combine to give me minus 12d, and then bring down the constant of minus 2. Final answer is 32d squared minus 12d minus 2. Again, you're responsible for copying these, but you're also responsible for any letters not shown in the video. So, example 5, find the product of each of the following. So we're still doing multiplication. It may not seem like it right now because you're looking at A and you're like, well, I only see one factor, right? X minus 3. However, remember we have a base, x minus 3, and an exponent 2. The exponent tells you to take the base and multiply by itself that many times. So if we were to expand that, we can rewrite it as the quantity x minus 3 times the quantity x minus 3. And now we're going to do what we did in the previous example. Everything in the first parentheses needs to be multiplied by everything in the second. So x times x will give me x squared. Again, law of multiplication, keep the same base, add the exponents. X times a minus 3 will give me minus 3x. Now we're going to multiply minus 3 by everything in the second. Minus 3 times x will give me minus 3x. Minus 3 times minus 3 will give me a positive 9. Combining like terms, the only thing here that we can combine is the minus 3x with the minus 3x. Finally, we combine variables first, highest exponent, x squared. Minus 3x will give me minus 6x. Bring down the constant of positive 9 for a final answer of x squared minus 6x plus 9. Skipping ahead to example D, same thing. We have a base, we have an exponent, so that tells me to rewrite it as r plus 2s times the quantity r plus 2s. Okay. R times r squared. R times 2s is going to be positive 2rs. Notice you just put the variables next to each other in alphabetical order because that tells me they're being multiplied anyways. 2s times r, again alphabetical order, that's positive 2rs. 2s times 2s is going to give me a positive 4s squared. Again, law of multiplication of exponents. Multiply the coefficients, keep the same base, and add the exponents. The only thing that we can combine here are the middle terms, 2rs plus 2rs. Now, variables first in alphabetical. R comes before s, highest exponent. So we're going to bring down r squared. 2rs plus 2rs is going to give us a positive 4rs. Now notice, even though it contains s, we put it first because it still has an r. And r comes before s, so we want to get rid of all the terms that have an r first. And then finally, positive s squared. For a final answer of r squared plus 4rs plus 4s squared. Once again, you're expected to copy A and D, and then any other letter we haven't done is up to you to finish. Example 6a. You are making square designs for an art project. You start with a square piece of construction paper with 8-inch sides. You reduce both its length and its width by x as shown. What is the area of the new square design? Express the answer in the standard form of a quadratic. Okay, so let's try to understand what's going on here. You're making a square design for an art project, okay? You can see the picture below. There's my square. Then it tells us you start with a square piece of construction paper with 8-inch sides. So from here to here, 8 inches. And from here to here, 8 inches, right? Making it a square because all 4 sides are congruent. Then we're told that you reduce. Reduce means you cut, you make shorter. You reduce both the length and the width by x as shown. So you take some scissors, you cut across a dashed line. On one side you cut a length of x, on the other side you cut also a length of x. So now the question is, what is the area of the new square design? So they want the area of this little square underneath. And they want the answer in the standard form of a quadratic. Standard form being ax squared plus bx plus c. Alright? Well, we have a square, which you can calculate the formula the same way you would a rectangle, length times width. So the original length was x, but you reduced it. No, the original length was not x, sorry. Let me cross that out, that was a mistake. The original length is actually 8 inches. So let's start with that. The original length is 8, but it was reduced by x. So we're going to take away x. We cut it off, we subtract it. That's the length of from here to here, 8 minus x. And we did the same thing over here. So this length right here is also 8 minus x. So we're going to have to multiply those two together because that's length times width. Okay. So you want to take your original measurement and then subtract what you took away from it. Do not start with x like I was about to. That would have been a mistake. Would have been awkward. Alright, starting with 8. 8 times 8 will give us 64. 8 times a minus x gives us a minus 8x. Then minus x times 8 minus 8x minus x times minus x. Using the law of multiplication, multiply the coefficients to give you a positive. Keep the same base. Add the exponents to get that. Okay. Combining like terms, the only thing we can combine are the minus 8x because they have the same variable and the same exponent. Keeping in mind too that we want to rewrite it in standard form. So variables first, highest exponent, x squared, minus 8x will give me minus 16x. Finally the constant, which was a positive 64. Keep in mind that what we did was just calculate area, so the whole thing, parentheses, inches, square because that was the original unit of measurement, square because you took inches times inches. Technically what we're using there too is the law of multiplication. Keep the same base of inch, add the exponents together to get that. So this right here would be final answer.